12. Algorithm design and problem solving. Chapter you will learn and you will understand how to show an understanding of abstraction. Show and understand the abstraction. Describe the purpose of abstraction. So abstraction, if you remember, is removing unnecessary details when trying to solve a problem. Produce an abstract model of a system by only including essential details. Describe and use decomposition. Remember decomposition, breaking down into smaller programs or smaller tasks, subtasks. Break down problems into subproblems, leading to the concept of a program module. Small program module. Through understanding that an algorithm is a solution to a problem expressed as a sequence of defined steps. Use suitable identifier names for the representation of data used by a problem and represent these using an identifier table. So like variables, the general term is identifier. And in a table, you will identify them and write down and prepare like explanation that will help to do the program. Write pseudocode that contains input, process, and output, all three together. And then write pseudocode using the 4 basic constructs of assignment, sequence, selection, and repetition. Assignment, that is like A equals 10, B equals 20. Sequence is the order of instructions. There has to be the correct order. Selection is where there are more than one path to be taken, how to take, depending on a condition. So generally, if then else, those are the one. And repetition is iteration is another term. Repetition, loops, using loops. Document a simple algorithm using pseudocode. Write pseudocode from a structured English description or a flowchart. Describe and use the process of stepwise refinement to express an algorithm to a level of detail from which the task may be programmed. So detailed so that you can transfer each statement into a programming language instruction. Use logic statements to define parts of an algorithm solution. Logic statements. What is computational thinking? So for computational thinking, you get 1, 2, 3, 4, 5 things. First is abstraction, removing of unnecessary details when solving a problem. If you mentioned it at the beginning. 12, task straight away, there's a task for you. Use the aerial photograph in figure 12.01 and draw a map just showing the essential detail for finding a route from landmark A to landmark B. So if this is the aerial map, in order to mark A to B, from A to B the route, you don't need these colorful gardens and lawns and the rooftops, the houses. You don't need. Just draw a line. That is it. Because abstraction is removing all unnecessary things. If you have all these things, it will be difficult to solve the problem. Finding a path to this one or calculate the distance, the time, various things. These are all unnecessary details. That is what abstraction is. Then there's another 4 things like that. One is decomposition. Program modules. That is, decomposition is breaking down a big program into small program modules. And procedures and functions are used for this. There are 2 types of subroutines or module. They are called procedures and functions. There's a slight difference between the two. The procedure doesn't return any value, whereas function return. A function will return a value. Calculate or do something and then return a value. So data modeling, another one. Analyze and organize data. Analyze and organize the data. and that's called modeling. You use queues. We have learned these things. You use queues and stacks. User-defined data types. OOP, object-oriented programming. Objects and classes, facts and rules, then random files. Random files also can have data. That will come in detail in chapter 26. Pattern recognition and finding common solution. Pattern recognition, like 1, 3, 5. What is the next number? It's 7. Likewise, if you know the pattern of the past things and the known things, and it's easy to give the solution to the unknown thing. Algorithm design. Develop step-by-step instructions to solve a problem. So those are the 5 things. Try to remember now itself: abstraction, decomposition, data modeling, pattern recognition, and algorithm design. What is an algorithm? In day-to-day life, user manuals tell you how to do various tasks, step by step. Example, how to change a wheel on a car, how to bake a cake. This will take these instructions to bake a cake. 1, these are numbered, the instructions. Measure the following ingredients, and they are given. 2, mix the ingredients together in a large bowl until the consistency of the mixture is smooth. Pour the mixture into a cake tin. 4, bake in the oven at 190 degrees centigrade for 20 minutes. 5, check it is fully cooked. See whether it's very cooked. 6, but don't burn your fingers when trying to check whether it is fully baked, right? Turn cake out of the tin and pull on a wire rack. That is the general instruction. Bake a cake. Recipe is the algorithm. The recipe is the algorithm. Ingredients are the input. The sugar, butter, and all that. Ingredients are the input, and what is the output? Cake is the output. Process is mixing and baking. Mixing and baking. Changing, both of those things will change these ingredients into a different product. That's what happens in computer. You remember in your lower classes, we learn data processed and output the information. Information is output. The same way here, the ingredients are there as data, then the mixing and baking, they are the processing, and that will give the output cake, baked cake. Now we are going to, as the decomposition, you remember breaking them down into breaking steps down into more detailed steps. Now we are going to break the second step into more detailed steps. Second is mix the ingredients together in a large bowl until the consistency of the mixture is smooth. So the numbers are there. You can give subsection numbers. 2.1, beat the sugar and butter together until fluffy. Add the eggs one at a time, mixing constantly. Sieve the flour and baking powder and stir slowly into the egg mixture. Add milk and mix to give a creamy consistency. Now, don't ask me why this is necessary. This is not a lesson on baking cake. This is on algorithms, how to write algorithms. So I'm not going to explain any of those things. Then here's another task for you. Write the steps to be followed to make a sandwich. Right. You will think that, oh, that is easy. But when you go to write, if you have not written before, you find it difficult. So don't skip this task. Please write all 3 tasks, write down and see. If the forum, you can post it in the group or whatever, you can discuss with the others also. Or you can send me a message. 12.03, expressing algorithms. A good solution gives the correct results. It's obvious, no? A good solution, for anything, for any problem, a good solution gives the correct result. Takes up as little computer memory. This is now specific about computing. First, I said anything takes up as little computer memory as possible. That is very important because memory is very expensive and executes as fast as possible. So the two things to consider are the memory space and the speed. The solution should be concise, elegant, and easy to understand. So there are more factors coming into a good solution. Now we are thinking of the assignment sequence, selection, and repetition, the four constructs. So assignment is, as I said, A equals 10. Yeah. You know why this arrow is used instead of equal sign? If you have forgotten, this value is transferred into this, assigned into A. It's not an equation. This value goes there to A. Always to the left side, remember. And the sequence is steps in order. Like if you give instructions to a person getting ready to go to school or office, you say at one point, wear the shoes. Next instruction is wear the socks. What will happen? Socks will be outside the shoes. So it has to be in the correct order. Selection. Selecting an action when there are more than one option. So if A is greater than B, there's one option. Then if this is not, then else. So you have to consider this. This is a condition. Logical condition. Is A greater than B? If it is true, if this condition is true, for example, if A is 5 and B is 3, then the condition is true, no? 5 is greater than 3. Then this happens, whatever that comes or what follows. But if this is false, supposing this A is 3 and B is 5, so 3 is greater than 5 is false, then else. Then this will happen, not that. So only one of them will happen. That is also important. Only one of them. Both will never happen. So easy to remember else. If it is false, like spelling is also a little bit like that, no? FALCE, then here ELSE. So, and end if is there. And all capitals, if you remember, the pseudocode should be in capital letters or block capital letters. And the fourth one is repetition, iteration or looping. Another term is iteration or even looping, but it continues in a loop, like loop. And repeat until A equals B is an example. There are other constructs like while, and for, next, like that. This is one. Repeat these instructions, whatever in between, until A equals B, until this condition is true. So in this case, the repeat until will work when the condition is false, and the moment it becomes true, it will stop. It will exit this loop and then go down. Now we are coming to variables, 12.04 variable. When a value is input, it is stored in a memory location for which the programmer gives a label or identifier. Variables should be given meaningful names, right? So if you want to have age, right, as a variable for the student's age and name for as a variable name for the names of the student, is fine. But if you have N for names and A for age, after some time, you will find the bottom of the program that you have used A, B, C, D, E, F, G, H, I, J, all the letters in the alphabet, and you don't know what is what. So you have to remember N. There must be some other number also, N. So name and number, you don't know which one is N and the other one is num or something like that. So better to use full names like student name, even better. STU name better than just name. At the exam also, they instruct, specifically they say at the beginning of the paper, write meaningful variable names. Then assignments, assigning a value A equals 10, A becomes 10. This is not, you might misunderstand this, but what I'm trying to say is assigning a value, this, yeah, we can change this in a different way. It should be this a equals 10 as an assigning a value. Then what happens? A is assigned the value 10. Then updating the value. How do you update a value? Now A, we want to update the value. We have to add 1 to A. So A equals, or A is assigned A plus 1. So A is assigned the value 11 because A is 10 at the moment. Plus 1 is 11. The rule here is you evaluate the right side. Get the answer on the right side of the arrow. Then put it to the left side. Only one variable can be on the left side. The left side of the arrow, you put the value there. That is why this arrow is also indicating the transfer of data to this side. Copying a value, B equals A. Whatever. B is assigned the value 11. B also gets the value of 11, which is BA. We also get the value of A, which is 11 at the moment. Then how do you swap a value? Swap two values rather. So first we have values 10 and 20 given to A and B. A is 10 and B is 20. We have to end up A becomes 20 and B becomes 10. How does it happen? Changing. First you take the value of A into a temporary variable. So temporary variable becomes 10. So now we have 10 in temp, 10 in A, 20 in B. Now we put the B value to A, then A becomes 20. Because this comes there. A becomes 20. And now we take from what is stored here, the A value, put it back to B. Put it to B. So that B will become 10. So that operation will make A become 20 and B will become 10. That is swapping value. And here is a task 12.03. Consider the following algorithm steps. Input a length in inches, calculate the equivalent in centimeters, output the result. List the variables required in an identifier table, write pseudocode for the algorithm. So what are the identifiers required? You need variable to input the length in inches. So you can even use the word inches for that, or INCH or whatever, something in or length, input length in inches or something like that. That will be the prompt. You should consider giving a prompt also. So that for that to remember output. In pseudocode, you output the question first and then input the variable. Then what are the other variables you need? You need a variable to store the output, the calculated centimeters, the distance in centimeters. Then output the result. So the result in centimeters, input inches. So you can write the pseudocode for that. Then logic statements. If A less than B, then statements, else, some more statements, and ending. What are the relational operators? Equal, you know about it, equal to is equal to, less than, greater than, less or equal to, greater or equal to, and this is not equal to, not equal to. Conditions are either true or false. You can't have any more than two values here. Two possibilities, only true or false for any of these. And this sign is the symbol for assignment, as we saw earlier. Example, num1 equals 10. So here it's a selection statement. If age is less than 13, then person is a child. It's a single condition. If age is less than 13, then person is a child. A single condition. Now here are two conditions. If age is greater or equal to 13, that is one condition. Age is less or equal to 19, another condition. And combined with the AND operator. So two conditions combined. And the output is then person is a teenager. So this is a combined condition. Task 12.04. A town has a bus service where passengers under the age of 12 and over the age of 60 do not need to pay a fare. Write the logic statements for free fares. Logic statements are these. These are the logic statements. We have to write how to, who will get free and who will have to pay. And you will realize that you have to input the age. That's all. When the user inputs the age, the program will tell, or the pseudocode, the operation will tell whether it's free for that person or he has to pay, he or she. And the eligibility is either less than 12 or greater than 60. They are the people who don't want, the little children and the old people. They don't have to pay. And here comes a number guessing game. The player inputs a number to guess the secret number stored. So you can imagine the computer will ask on the screen, there's a secret number. Can you guess it? So the player inputs a number to guess the secret number stored. If the guess was correct, output a congratulations message. If the number input was larger than the secret number, then say secret number is smaller. If it is larger, then say secret number is greater. If it is smaller, if the number input was smaller, then you say the secret number is greater. We can rewrite the number guessing game steps as an algorithm in pseudocode. It is like a structured English or just a statement, problem statement. Description of the problem. So here it is, set value for secret number. So say 35 or something like that, you set it in the program. Input, guess. So enter your guess or something will come on the screen and the user will input. And where will that in the number, the guess will be stored? It's in this variable. In the variable name guess. If, and now you can check. If guess equals secret number, then the first time itself has cracked the jackpot now, won the prize. Then output, well done. You have guessed the secret number. Else, which means not equal, it's not 35. Supposing, imagine that we are having number 35 and he has input like 70, 100 or 1 or 3 or something. And in that case, you can't output this. This will be done only if the operator of the user enters 35 at once. Right? It is the jackpot. Otherwise, if the guess is greater than secret number, which means if the guess was 70, then it's greater than the secret number, which is 35. Then output secret number is smaller. Else, if you enter 25 or something, output secret number is greater. End it. That's it. Then the complex conditions. Earlier one used simple condition, single. Then the complex conditions is if guess equals secret number, then you will know that these are parts of programs, are not there. The input is not there, no? Here. Straight away we are taking the variable. So you must realize that, you must be aware of it. This is not a full program. This will not work. If you try to copy this and put into the Python and change the code, not work, because it will ask for various things. Where is the guess? Guess is not defined and various things. But this is only a part. So we have to learn only a certain thing in this. Here we are going to learn about the complex condition. How more than one condition, they have been combined. So if guess is equals secret number, then output, well done, you have guessed secret number, that's okay. If guess not equal to secret number, right, that is one condition, and number of guesses equals 10, two conditions. And here and. If both conditions are true, which means a complex condition here, then output, you still have not guessed the secret number. That means we have given several times, there's no loop also here, there's only it looks like just one entry, but this looks like number of guesses looks like the user has been given many times, and it will say if guess is not equal to secret number and number of guesses equals 10, that means 10 times he has um, guessed, and the secret number is not correct also. The guess is not correct. Then the output is you still have not guessed the secret number. Else means one of these false. Either the secret number is correct or guess number of guesses not 10. In that case, output secret number is, outputs, else. Else means if guess is greater than secret number. That means not equal. If it is not equal, first, now let's take it again. If it is equal, right, you do this, and then if it is not equal, you check whether it is the 10th time, right? Or whether the guess is not equal to secret number. So output, you still have not guessed the secret number, and else, that is finished. Huh? This is finished. But else means you have still not gone to the 10. If guess is greater than secret number, then output secret number is smaller. Else output secret number is greater. The only difference here is these two conditions are combined. It's a complex condition. Then nested if statements. Worked example 12.02 from the book. The problem to be solved is take three numbers as input and output the largest number. So input number 1, number 2, number 3. If number 1 is greater than number 2, this doesn't look nice, no? Input number 1, input number 2, input number 3, like in grade 6, 7 or something. But since we have to learn from the beginning, so let's take from stage to stage, then we'll find later on more efficient and more elegant coding. At the moment, we just simple way. Why I'm saying this is not the best, because if there are 100 inputs, there's just 3 numbers here, but if we say take 100 numbers as input and then finish, you will take about 1 hour to type these things or just copy and paste. So at the moment, we take this, right? You don't have to worry, but learning how things evolve. So input number 1, input number 2, input number 3. If number 1 is greater than number 2, now we are checking. If number 1 is greater than number 2, that is we are comparing these two. Then we know that number 1 is bigger. No? If number 1 is greater than number 2, number 1 is bigger, obvious. If number 1 is greater than number 3, another check. First we check 1 and 2. If it is greater than 2, check with 3. And still, if it is greater than number 3 also, then obviously number 1 is the greatest. So output number 1. Because it is greater than 2, it is greater than 3. Else means first thing is true, this is greater than 2, but the second one is false. Therefore, 3 is greater. Because 1 is greater than 2, but 3 is greater than 1. So 3 is the greatest. So output number 3. Then else, that means 1 is not greater than number 2, then 2 is greater than 1. Number 2 is bigger. So if the execution comes here, you know that if else, these things both will not happen. Then will happen. If then happens, then else doesn't happen. If else happens, then doesn't happen. One of them. So when you come here, execution comes here means number 2 is bigger. Then we are checking again whether number 2 is bigger than number 3 also. If so, then number 2 is the biggest. So you output number 2. Else means number 2 is not bigger than number 3. Then number 3 must be bigger. Output number 3. Indeed. Okay. So we have checked for all 3. In some place, 1 will come, another place, 2 will come, another, in 2 places, 3 will come, yeah, in this case. But not always, only one of the conditions. Only when the correct conditions meet, those will be output. Key term, nested if statement. conditional statements within conditional statement. Worked example 12.03 using selection constructs, that is alternative method. The problem to be solved, take three numbers as input and output the largest number. Same question. This time we are changing not number one, number two, number three. We are inputting biggest so far. We are using this variable biggest so far. The very first number will go into that. Then input next number, that is the second number. Variable use this next number. And we are comparing now. If next number is greater than biggest so far, that means this second number is greater than first number in our words. If next number is greater than biggest so far, then biggest so far becomes next number. That means if this was 5 and this is 7, next number is 7, so it's bigger than biggest so far, which is 5. Then biggest so far, which is 5 now, becomes next number, which is 7. So this will happen. It will happen to next number because next number is on the right side. Here the change takes place because the arrow is only here. The other places only comparisons. So here if next number is greater, then next number value will go to biggest so far. Nothing will happen to next number. So next number is 7. Biggest so far is also 7. Then what happens? Input next number. Now we have found the biggest so far is 7. Input next number, that's the third one. If next number is greater than biggest so far, let's say, shall we take it as 9? 9. And it is true if next number is greater, 9 is greater than biggest so far because biggest so far is 7. Then what happens? Again, biggest so far gets updated and nothing happens to next number. Right? Next number remains 9 and biggest so far becomes 9. And at the end, output biggest so far. So we get, in this case, what do we get? We get 9. So that's correct, no? So that way you can check with other values. Then you should get the biggest so far. Now let's imagine that biggest so far, the first one is 100 and the next number is 50. So will it get updated here? Because 50 is not greater than biggest so far. So this will not happen. So biggest so far will remain 100 and next number will be 50. Input next number, maybe 75. Is 75 greater than 100? No. So biggest so far will still be 100. And next number will not change, it's 75. So anyway, whichever way you take, biggest so far will be the biggest one, the highest, and output of that will get to the answer. Now we have to note this. Only two variables are used here. Okay? Biggest so far, next number, only those two. Whereas earlier we used 3. Number 1, number 2, number 3. And if there were 4 numbers, we would have used number 4 also. There's 4 variables, but here only these two because only to put another if and if. Input another next number. But yet the number of variables is 2. Only these 2 variables because they will be overwritten. The conditional statements are not nested and do not have an else part. Not nested. Within this if there is no another if, in this no if, and there is no else also. This makes them easier to understand. So this is better, isn't it? Looks better. And if you just the sight of it even, have a look at it. Yeah, this looks big and complicated. But here this looks concise, complex. This algorithm can be adapted more easily if further numbers are to be compared. So if there are 100 numbers, what do? You use a loop and only this comparison will be done, even smaller than this. So here it is. We are using repeat until, right? Just to note, no repeat until in Python. That's for your information, but we can get over that situation by using the other loops. What are they? For and while. So here is worked example 12.04 using repeat until. Input bigger so far, so there's no problem there. There's no change there. Input bigger so far, the very first one. And counter, we set the count at 1. Repeat, input next number. So input next number comes here. First input bigger so far. Repeat, input next number. Counter equals counter plus 1. So the counter starts ticking. If next number greater than bigger so far, then bigger so far becomes next number. Very simple, no? What we have already seen. That part is there. End if, and that's it. Until count equals 10. So if it is 10 numbers, you just go on doing this for 10. 10 passes. The loop is 10 times. So at the end of it, once the loop is over, output biggest so far, you will have it. Whether it's 10 or 100 even, the biggest so far will have the biggest number. If you are using for next, still very small and similar, but there are differences as you know. You don't need a counter for this because it's automatic. So start with input biggest so far, no need of a counter. For counter equals 2 to 10. Why 2 to 10? Because the first number is already input. So we need only 9 more. And input next number. If next number greater than biggest so far, then biggest so far is next number. That's the same old story. And next counter will take you back here and go on till 10. Biggest so far. Output biggest so far will give it. Just a revision question. What's the difference between the repeat until and for next, or what can you, how do you classify them? What type of loop is this? What type of loop is that? Right. The answer is, this is a post condition loop and this is a pre-condition loop. Post condition because the condition is checked at the end. Pre-condition because condition is checked at the beginning. Pre and post. Then what is rogue value? A value used to terminate a sequence of values. Here earlier, it was fixed, 10 times. Goes on till 10 and in this case, there is no number, fixed number, but the user will decide. In the earlier cases, the programmer knew. The programmer knows that it's 10 times. In this case, the programmer doesn't know when it will end. Right? Because only the user will end it when he wants. What is this? Rogue value. A value used to terminate a sequence of values. Rogue is not an expected person. No? A rogue to a home who burglar or rogue is not an expected person. So imagine why are we using this term here? Imagine entering marks to a student mark system. The expected marks are 0 to 100. 0 is expected. 1, 2, 3, 50, 85, 95, 100. All those numbers are expected. But if you put -1 or if you put 101, it's not expected. So we can make use of that kind of thing to finish. Because we don't know, let's say, we don't know how many students are there. We don't know how many applications are there for the admissions. So just take application by application and the user will enter, or the operator, data entry operator will enter these things into the computer program. When the last one comes, when it's finished, after entering the last one, he will input either 9999 or -1111 something, which is unexpected. At that time, the program stops. So, rogue value and repetition, how do we do this? Input biggest so far, right? Repeat, input next number. If next number greater than biggest so far, then biggest so far is equal to next number. Nothing, no difference, no? Nothing new in this. Whereas what is new here is until next number equals 0. We are inputting three numbers, nobody, you don't have to compare now 0 and something. So the moment the user enters 0, it will finish. Because this will go on for 1, 2, 100, anything, but until it becomes 0. When the user enters 0, it will stop the loop, then go there, go beyond the loop, output bigger so far. It's a rogue value. Then while also, same thing happens, input next number, because so far equals next number, while next number not equal to 0. There, of course, until next number equals 0. But here, precondition, at the beginning itself, it will check. While next number not equal to 0, do this, the following statements, input next. End if and while and output because so far. The rogue value here is 0. Worked example 12.07. Allowing repeated guessing. Earlier we didn't allow the user to give repeated guesses. Just fun and finish. So set value for secret number. Set value for secret number. Repeat the following until correct guess. And that's a loop. Input guess. Count number of guesses. Compare guess with secret number. Output comment. Output number of guesses. This doesn't look like pseudocode, does it? This is different. No, you are using for. The word for is used here. The, repeat the following. You don't use this in pseudocode. Correct guess, no? So this is what you call structured English. Output number of guesses. And so the secret number we set as a random number. So here's another different thing we are going to do. Because here set value for secret number, earlier I give an example of 35, setting secret number as 35. But now, even the programmer will not know. Earlier programmer knew it was 35. Now, even the programmer will not know for each game what the number will be inside. That is because we are going to have the secret number as a random number. So it's unpredictable. You don't know which number will come. The number input by the player as a guess. The count of how many guesses the player has made so far. So how are we going to handle that? Start and set secret number to a random number. So you don't have to tell how it is done in pseudocode. Of course, in Python, you can generate as a random number, but here this is enough. And input guess the secret number into a variable called guess. This is the prompt, guess the secret number. And set number of guesses to 1. So at that point, you set the number of guesses to 1. That's a count. And ask the question, is the guess equal to secret number? If it is here, that means the very first time they guessed and output, you took number of guesses. Sorry, number of guesses is 1. This is a variable. Number of guesses is 1. Guesses is the constant or the explanation or the description. So it will be you took 1 guess or guesses here, right? And end. If not, if this is wrong, if the guess is wrong, that means no, it's not equal. Then set number of guesses to number of guesses plus 1. So add another one. Another one. And guess, is a guess greater than secret number? If so, input guess a smaller number. So you give another chance. Give another chance to enter another guess. If it is not greater, then it's smaller. Input guess a larger number, like giving a clue also. Giving a clue for the next input. Guess a larger number and input to the variable guess. In either case here, whether it's larger or smaller, you come back here to the repetition, the beginning of the loop. So you have input 1 here, either this or that, another number is input. Then it starts again checking, is the guess equal to secret number? If so, yes, and the number of guesses in this case, what we did now is two guesses. Otherwise, you go on until the guess is made and end somehow. And the number of guesses will be given, it's counted. So in pseudocode, what you can do is secret number equals random. That is enough. You don't have to specify how the random number is generated and all that. Just secret number equals random. Number of guesses equals 0. These are the initial values. Repeat input guess. Number of guesses equals number of guesses plus 1. You add 1. If guess is greater than number, then that means the player is given the message to input a smaller number and if guess is less than secret number, then player is given the message to input a larger number and if until guess equals secret number. Until guess equals secret number. So this will go on until when this is equal, the correct number is guessed, then it will exit the loop, the post condition loop. It will exit the loop and output the number of guesses. So at that time, the number of guesses is the outdated number, updated number will be output here. Then pseudocode for the number guessing game with a precondition loop. Secret number equals random, input guess, number of guesses equals 1, while guess not equal to secret number 2. So while this is a precondition, while guess not equal to secret number. So if the guess is correct, then it will exit very first time and number of guesses only 1. Because number of guesses is already 1 here. If in case this guess, what is input, is equal, none of these will happen. Well, these will happen only if it is not equal. Check whether it's big or whatever it is and give the appropriate message. If not, straight away or whatever, whenever this becomes equal, by guess equals secret number, it will exit this and output the number of guesses. Worked example 12.08. That is running total equals 0. So we are going to total up some numbers. Running total equals 0. For count equals 1 to 10. Input next number. Running total equals running total plus next number. Now this need not be next number. It can be even number, right? Because in this case, there is no other number. Only the numbers. If it is 10 numbers, all 10 numbers will be input and will be added to the total. Running total. Because these are very descriptive. That's why running total. Otherwise, just total is enough, no? Total equals total plus number. But here, very descriptive. We will also have to learn that method of giving descriptive names for the variables. So next count, that will do for 10 times and then output running total. The accumulator, this is called accumulation also. Running total equals running total plus next number will give you at the end the total of all 10 numbers and that will be output running total. And if you want to calculate the average equals running total divided by 10. 10 is because there are 10 numbers. And output average. Worked example 12.09. Using nested loops. The problem to be solved, take as input two numbers and a symbol. Output a grid made up entirely of the chosen symbol with the number of rows matching the first number input and the number of columns matching the second number input. For example, if you input 3, 7 and this hash mark, the result will be this. How come? Because the first one is rows. Always remember rows and then columns. First rows, so 3 rows. 1, 2, 3. And the second Input is 7 for columns, 7 columns. So 1, 2, 3, 4, 5, 6, 7. And this is the symbol. If this was an asterisk here, all these will be asterisks. So can you think of the variables you need to use? Let's list them out. What are the identifiers? Think for a little while. Pause the video and then think for a little while and then see afterwards. If you don't get the answer, listen to this now. You need the number of rows. No? First one. So you can say rows. Explanation is to store. Can even say like that. To store number of rows to display columns, number of to store what is symbol. So you can even improve it like to input and store the symbol desired. All your own words will be the best. I'm telling you, your own words will be the best, not the textbook words. Input and store the number. So here also, input and store. Oh, sorry. Input and store number of rows. Then what happens afterwards? What is the structured English for this? What we are going to do now. Again, pause this video and watch it after a little while because I'm going to show this now. Input number of rows, input number of columns, input symbol or row counter equals 1 to number of rows or column counter equals 1 to number of columns. Output symbol. So this is actually not structured English. So structured English you can write, your own like English, but this is the pseudocode. So input number of rows, input number of columns. So you get 3 and 7 and input symbol. For that, you will get this symbol, whatever that is to be displayed. Then you start a loop for row counter equals 1 to number of rows. So what will be this? 1 to 3 in this case. In this case, the row counter equals 1 to 3. That is for the 3 rows. So first you start with the first row and go on displaying these 7 columns. For that, you use an inner loop. This is called inner loop. This is the outer loop, then this inner loop, a nested loop here. For column counter equals 1 to number of columns, which is 7. So it will be 1 to 7. Output symbol. And then you output this, whatever the symbol, that is in this case, it's a hash sign, hash mark, without moving to next line. Because otherwise, when you repeat like this loop, every output statement will go to the next line. The cursor will go to the next line. But there is a way in Python also, there's a way of putting it into keeping it on the same line. But in pseudocode, there's no way of showing that. So only way is to give a comment like this without moving to next line. Then the next column. So that means you enter here, the very first one. First column is printed, then the column counter equals increased to 2. Then the second time the symbol is printed. Then the column count is equal to 3. That means the third column. Likewise, it goes on until this 7 is done. Finished. Then output new line. Output a new line. That is to move to the next line, the next row, this second row here. And then what happens? How do you go to the next row? When you say next row counter, it goes there and then add one. Adds one to this. Row counter becomes two. So that means here. This is the place. And second row, that is second row. Then again start. Column counter start from 1 to 7 again. 1 and displaying this up to 7. Go to the next new line and then row counter comes in third line finally. That is how this ends. Now we come to stepwise refinement. What is that? Imagine that you were playing in your garden and the ball or the shuttlecock went a house roof and got stuck there. You have to take it if you want to continue playing. Imagine that there is no extra shuttlecock, so you have to somehow get it. The roof is 10 feet high. Will you take one giant step to the roof? No, you can't. Then what will you do? Climb in small steps. Take a step ladder and one by one go. This is what we do in stepwise refinement. We use stepwise refinement to break a complex task into smaller and manageable subtasks. When it is applied to a programming task, the following basic constructs are considered. In which form do you prefer to eat bread? Is it the loaf? If you want a loaf, do you like to eat like that or you want in slices? Obviously, the slices. No? In the same way, when big tasks are broken down to smaller subtasks, they are easier to manage. You have been learning this several times. Drawing a pyramid using stepwise refinement. So let's take this to the next page. That's about example 12.10 from the book. The pyramid should look like this, and A, the letter A is used for this. This is the structured English. Set up initial values to repeat output number of spaces, output number of symbols, that is output spaces is here. How many spaces before displaying A? Then output number of symbols. Here is 1, here is 3, 5, like that it goes on. So it has to be generic, it has to happen for all the steps. Adjust number of spaces and number of symbols to be output in next row. So when you go to the next row, the spaces are different, number of symbols are different. Here again spaces are less, symbols are more. Here spaces are only 1 and symbols are more, increasing 2 by 2 here. And the final one, no space, and the maximum has come, it's finished. Until the required number of symbols have been output in one row. So suppose it 1, 2, 3, 4, 5, 6, 7, 8, 9. If the requirement is to have the base 9 symbols, then that's it, finished. So let's imagine, now I want you to think, do some research. When you have the loop 1, the first loop, number of spaces, now that is for number of symbols 9. In this case, Yeah, like this. If it is 9, it's 4. No? 1, 2, 3, 4. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the base is 9. Then it has to be centered here. And therefore, you have to have 4 spaces. Then 1 symbol. Then here 3 spaces next row and 3 symbol. 2, 1, none. So how? How come? If it is 7, to reduce, to take this 7, then this will move here and it will be 3 spaces. If it is 11, it's 5 spaces. So what is the formula in case if you want to have 101, and it has to be odd number also, but realize that's an odd number. And how do you calculate this? If you look at this, you should be able to get the formula, right? If you reduce 1 from there and then divide by 2, or do the integer division also, it gives the whole number, or reduce 1 and divide by 2. So this is 8 divided by 2 is 4. Here, 6 divided by 2 is 3. 11 divided by 10 divided by 2 is 5. And here, it's 100 divided by 2 is 50. So that should be the way. So loop 1, use print or display 4 spaces. Then number of symbols is 1. You start with 1. Then the loop 2, the second loop, number of spaces is 3. You have to reduce 1. Then number of symbols increase by 2. Loop 3, number of spaces decrease by 1, increase by 2, increase by 1, decrease by 1, increase by 2. Likewise, the number of spaces becomes 0 here, and the number of symbols, the max number will become 9. So identifier table. What are the identifiers needed? Symbol. We need the symbol, that is the character symbol, to form the pyramid. Max number of symbols, that is the base, right? The number of symbols in the final row. Number of spaces, the number of spaces to be output in the current row. Number of symbols, the number of symbols to be output in the step 1. Step 1, remember, set up initial values earlier. Away start. Expands to input symbol. 1.1 is input symbol, then input max number of symbols, then number of spaces equals max number of symbols minus 1 divided by 2. We looked at this earlier, a little while ago. And number of symbols equals 1. That is, for the very first time, it's 1. At the right top, there is only 1 symbol. Then step 1.2, this input max number of symbols also can be broken into input max number of symbols expands into repeat input max number of symbols until max number of symbols mod 2 equals 1. What is that? That is the remainder. When you divide by 2, whatever the number input, divide by 2, the remainder should be 1. Then only it's an odd number. So until that is 1, you repeat. You enter number. If you enter a even number, it will ask you to enter again. When you input odd number, it will exit and then you carry on. So mod as a comment, mod 2 gives you a remainder after integer division by 2. So what is the final version here? Set values, input symbol, so same thing repeated again here. Input max number of symbols mod 2 equals 1. Number of spaces equals max number of symbols minus 1 divided by 2. Number of 1. Then repeat. This is the outer loop for I equals 1 to number of spaces. That is a output space without moving to next line. So that, remember, we did earlier. Without moving to next line. In pseudocode, that's all we can do. Just make a comment. The next type, that means this 1 to number of spaces. Number of spaces is 4 at the beginning. So 4 spaces will be input. That is, if the max number of symbols is 9 provided, right? We assume that it's 9. Then it's 4 here, number of spaces. Then output number of symbols. What's the number of symbols? Is 1, no? Remember the number of symbols is 1 at the beginning. Then output symbol without moving to the next line. Next line. So that loop is also over. Output new line. That is move to the next line. Adjust values for next row. Adjust values for next row. That is number of spaces equals number of spaces minus 1. That is okay, no? Because we are reducing the number of spaces. We saw it in the identifier table also, or the calculation in the structured English one we saw. Reduce 1. So which was 4, now it will become 3. And number of symbols plus 2. Early it was 1, at the right at the top, there's 1 symbol. Plus 2, then it will become 3. That's how it becomes symmetrical. Until number of symbols is greater than max number of symbols. So when the max number of symbols becomes 10, that is, you have come to the max. And then that's finished. Now is a different one, 12.06. Use stepwise refinement to output a hollow triangle. For example, two input values A and 9 result in the following output. A and 9. That's all. That's all you input. The symbol is A and the max number is 9. So the structured English is yeah, this is here. Get another one. Repeat. Output leading number of spaces, that is this side. Then output symbol, then middle spaces, something new. We didn't have it in the pyramid because it was solid. Here it's empty. So middle spaces, number of spaces here, symbol again. Because this side also you have to fill up. Then just number of spaces and number of symbols to be output in next row. And go on till the required number of symbols have been output in one row. That's a max number. Then we come to modules. Procedure. There are two modules. There are procedures and function. Procedure is a sequence of steps that is given an identifier and can be called to perform a subtask. Function, a sequence of steps that is given an identifier and returns a single value. Function is part of an expression. Function call is part of an expression. So the difference here between these two are this returns a single value. So when pseudocode call procedure XYZ, that's the way in pseudocode. In flowchart, the simple slight difference here, you have a line here on either side and the same statement called procedure XYZ. Worked example 12.11. The problem is the same as in worked example 12.10. When we want to set up the initial values, we call a procedure using the following statement, call set values. So the top level is call set values. And what happens is, I've given colors, it's easy. When the set values is encountered, imagine that the execution is going like this, the CPU taking this one. Call set values, the execution will skip all these things and go to this one. Sorry, this is earlier. Calling for procedures, that's a description. It will go to this part, procedure set values. When say call set values, go to procedure set values. And there it goes input symbol, call input max number of symbols. So it won't go to this one. The execution will not continue here. It will go into input max number of symbols here. So let me draw and show you. This will go into this. And here it goes. From here, it will take you there. Likewise, the colors, it's easy to follow, right? If you follow the colors, you will know Then afterwards, what happens? When you go into input max number of symbols here, repeat input max number of symbols until max number of symbols mod 2 equals 1. That is input the odd number. Then end procedure. Then what happens? Then what happens? Now you go back to where you came from. Right? Where? You came to this place and finished all this. From where? From here. From to here you came from there, and the next one is here. So you repeat. This will take you back to this one, number of spaces. Right? Or else, when you have this, yeah, that is finished. So you go back there. Otherwise, you would have continued, but you can't. So you come here then. Then afterwards, what happens? From here, you go to, from where did you come here? You go to that place. Very important, learn that. From here, you go, you do a number of, come here, you come here. Once you finish this section, then you come here. And you don't go here. You don't go to this place. From here, once you finish, you go to number of spaces, you do this. And when you finish that, where did you come from? You came to call input max number of symbols. That's set values from here. You finish this and then come here, set values. You go to this place and continue down. But when you come here, output spaces, you encounter all output spaces, then it's here. So from here, you don't go to output symbols, you go here. Very interesting. If you really understand this, then it's very easy. Then what happens? Afterwards, you do that blue one. Once you finish that, go back to this place and do output symbol. Then output symbols will be down somewhere else. Here. Likewise, if you follow all, it will finish, go up to all the, will finish up all the colors. That is how. This is with modules. Earlier we didn't do with modules. That's a difference. Procedures and functions. There are no return functions. So there are no functions. All will notice that all are procedures. Then work example 12.12, drawing a pyramid using modules. So the same principle, you go on, all set values, repeat, all output spaces, all output symbols, number of spaces equals this, number of symbols that, until number of symbols equals greater than max number of symbols. This top-level solution follows three procedures. It also makes use of two functions in lines 5.1 and 5.2, these two functions. Right? Why? Because this is the way you use functions. We learned earlier, if you remember, function is a part of an expression. So, number of spaces equals, this is a function. It will do the work and return a value, will assign. Whereas in the procedures, there was no thing like that. All output spaces, call out symbols, but this is a function. Right? So these two are functions. Then procedure set values. Input symbol, max number of symbols equals validate max number of symbols. Validate max number of symbols, can you remember earlier? Then it goes to the input and odd number, this one. Validate max number of symbols. Returns integer. See the functions? Validate max number of returns integer. So at the end, after calculating this, return max number of symbols. That is why it will get here number of, uh, yeah. Then you get the number of symbols return. Other places you don't. And another thing to remember is, or note, this is procedure, end procedure, and this is function, and this is end function. Okay. So we have to note the differences in order to understand it fully. Then the usual way, procedure output spaces for count equals 1 to number of spaces, all that is done. And here is the other function. Function adjusts number of spaces, returns integer. This is the way to write. Returns integer. You have to give the data type here. So number of spaces equals number of spaces minus 1. Right? In the beginning, we reduce 1 no for every line. And then return number of spaces. So that when you go to input the display the number of spaces, it will be 1 less this time. Like that, it goes on. Then here's another function. Adjust number of symbols. Also return number of symbols there. One benefit of using modules is that individual modules can be reused in other solutions. That means you have this, like at the very beginning, as I told you, when making a cup of tea, some time ago, I told you, the boiling of tea, boiling of water is one module, brewing tea another module, and adding sugar is another. So that boiling water can be used, the same module can be used for making coffee also, no? Isn't it? It's common. So instead of writing the instructions again from the beginning, from scratch, you can reuse these things. That is the advantage. You can call them by name. Reused in other solution. Therefore, modules should be designed to be self-contained. That is another thing. You can't, if you separate them, isolate them and take it to another solution. If it says this is missing, that is missing, then there's no use. Self-contained is that, self-sufficient. That means they should not rely on external variables. They all should be there, built in. All variables that are required by a module should be passed to it using parameters. To illustrate this, look at worked example 12.13. So passing parameters is another one that is very important. Drawing a pyramid using modules and parameters. Call set values, right? And give this symbol, max number of symbols and number of spaces and number of symbols. So you like give all these values through this. When you call the set values thing, you give these values also. Maybe asterisk, max number of symbols, 9, number of spaces, 4, and number of symbols, 1. At the beginning, these will be used to start. So repeat, all output spaces, and the number of spaces will come from here. Because it's passing, it's going through this module into this one. So number of spaces, 4. Output 4 spaces, that will happen. Then call output symbols, number of symbols, that will come from here, number of symbols. And the symbol, and also the symbol, so that will be there. So that symbol, so many, like 1 in the first time it will be 1. Then number of spaces equals, so this is adjustment, right? The function adjusted number of spaces, and you pass the number of spaces will be 4. No? It will be 4. When you go there, you will find that that is -1. Somewhere it is reducing, -1, and the value calculated will be returned to this number of spaces, and number of symbols also same way. And until number of symbols greater than, so until this will go on until you reach the maximum, the base number. Then procedure, set values, symbol, max number of symbols, number of spaces, number of symbols. So that is also coming from there. Set values. Then set values is the very first one, called set values. This will come procedure. So what is the procedure? Refer to this one. all set values, what will happen with this data. Procedure set values, symbol, the same thing will be there, set symbol, number of spaces, number of symbols. Then input symbol, right? Input symbol, max number of symbols equals validate max number of symbols. Validate, remember? So that has to be number of spaces equal max number of -1 divided by 2. So number of spaces will be if it is 9, it will be 4 here, number of spaces. And here max number of symbols, whether it's odd or not. Then number of symbols equals 1. That's for the first time in procedure. Then you go to validate max number of symbols coming from here. Let's validate number of symbols here. Validate max number of symbols, like that. Validate number of symbols also there. Validate max number of, function validate max number of symbols. Returns integer. Repeat input max number of symbols, the mod function, and until it is odd number, it will go on and return. So if it is 9, if it is 8, nothing will happen, it will repeat. It will ask you to enter again. And when you finally enter an odd number, that will be returned. Right? Then you continue, because this return will be there. Validate max number of symbols. This will go there to this one, max number of symbols. Then the next one is number of spaces. So procedure, then output spaces, number of spaces. For count equals 1 to number of spaces, output space. So this is going on, doing the needful. I put the colors there. It's easy. Local, you have to understand. There are two things. Local variable. A variable that is accessible only within the module in which it is declared. So this for the count 1 equals that this number of spaces, this count 1 is within this, and count 2 also within the procedure. So that is called a local. The global is, so both these are local variables. They are not available to any other function. If you use them there, it will say not defined. That variable is not defined. Then the global variable is variable that is accessible from all modules. That will be available throughout the whole entire program. That is the difference between local and the global variable. So that is the end of chapter 12.